Today we're going to discuss the fundamental trigonometric identities. The fact that these are the fundamental ones means that these are the basis for how we can move forward. Identity here is something like 1 equals 1. This is a true statement. Itself equals itself. So some of the reciprocal identities that we already know, reciprocal meaning the flipped version, one of them is that the cosecant of theta is equivalent to 1 over the sine of theta. A second one here is that the secant of theta is equivalent to the reciprocal of cosine, and the cotangent is equal to the reciprocal of the tangent. And one thing to know about those is that the left and the right side are exactly the same. They are identical. For the quotient identities, again, the left and the right are going to be exactly the same. The two that we need to have here are going to be that the tangent of theta is equivalent to y over x or sine over cosine. And for cotangent, that's equivalent to x over y or cosine over sine. I would emphasize here the equivalencies or the identities that involve sine and cosine. So I'm most concerned with these four. Should we know that the cotangent of theta equals 1 over tangent of theta? Yes, but that's not going to be utilized as much moving forward. Before we get into the Pythagorean identities, I want to make a quick note here about notation. One thing to know is that if we have the cosine of theta times the cosine of theta, that's the same as the cosine of theta, that quantity, squared, which is most commonly written like this, the cosine of theta squared with the 2 on the cos. This is not equivalent to the cosine of theta squared. That last notation there will often mean that the theta is squared, but not the entire cosine. So we're either going to need to put the parentheses around, or most commonly, you'll see this little exponent of 2 placed on the cosine. For Pythagorean, what comes to mind? The square of a leg plus the square of another leg equals the hypotenuse squared when we're talking about a right triangle. If we go back to our unit circle, when we put a right triangle inside, we were able to simplify for this triangle inside the unit circle that one of the legs was x, another leg was y, and the hypotenuse was 1. And if we square 1, we just get 1. We're going to go a step further with this and develop our first Pythagorean trig identity. X is the same as cosine, so we're going to say that the cosine squared of theta plus y is the same as sine. The sine squared of theta is equivalent to 1. If I were to take any angle, let's call a 45-degree angle or a pi over 4 radians, and I were to take the cosine of that 45 degrees, square it, add it to the sine of 45 degrees, square it, I would always get 1. From this, we're going to develop two other Pythagorean identities. The second one is going to come from dividing our first, cosine squared of theta plus sine squared of theta equals 1. If we divide every term here by cos squared, and you can see there I'm leaving off the theta, but that really is involved. Cos squared divided by cos squared will give me 1. Sine squared divided by cos squared will give me tangent squared. And 1 divided by cos, if I go back to my reciprocal, that would give me secant squared. You can see a lot of times I leave the theta out here, but really that should be tangent squared of theta equals secant squared of theta. Sometimes we'll use x instead of theta. To develop our third and final Pythagorean identity, we're going to take our original, which was cos squared plus sine squared equals 1. We're going to divide everything by sine squared of theta, and we'll get cos squared divided by sine squared to be cotangent squared. Sine squared divided by sine squared to be 1, and 1 divided by sine, going back to my reciprocals, to be cosecant squared of theta. Very important. Cos squared plus sine squared equals 1. From that, we can divide everything by cos squared to develop our second one. And from our initial, we can also divide everything by sine squared to develop our third one. The most important will be this first one. However, the other two are relevant moving forward. How are we going to use these? Again, these are going to be the basis for true statements. Itself equals itself, 1 equals 1. What we're going to do now will be called a trig identity. The question will say, prove that the following equation is true. The equation that we're going to work with today is that the secant of x plus 1, that quantity times the quantity of secant x minus 1, divided by the sine squared of x, will always equal the secant squared of x. This is a true statement. This is an identity. The left and right sides are exactly the same. But how do we prove it? We prove it by algebraic manipulation. We prove it by using our fundamental identities to somehow manipulate so that the left and right sides are exactly the same. One rule that we're going to set here is that we cannot manipulate both sides. We may only manipulate one side of the equation. In choosing which side I'm going to manipulate, I will almost always manipulate the more complicated side and simplify it down to be the more simple side. So we already know the answer here. The answer at the end is going to be that the secant squared of x equals the secant squared of x. But somehow I need to get the left side to equal the secant squared of x. So where am I going to start? I'm going to start by FOILing the numerator. I'll get secant squared of x minus the secant of x plus the secant of x minus 1 divided by the sine squared of x. I can't touch this right side. I'm going to then combine like terms. I'll get the negative secant of x and the positive secant of x to cancel out. At this time, I'm going to use one of my trig identities. I'm going to use one of my Pythagorean trig identities that says that the secant squared is equivalent to the tangent squared plus 1. And I'm going to substitute this in. I'm making a little note here that I'm going to substitute tan squared plus 1 in for secant squared. So when I move down, tan squared of x plus 1 minus 1 over the sine squared will still equal my secant squared. I can combine like terms. The 1 and the negative 1 cancel out. Now I have tan x squared and I have sine x squared equals secant squared. I'm just going to rewrite this. I don't know that this step is necessary, but this is the same as tangent squared over 1 times 1 over the sine. That will equal the secant squared. I'm going to do one last substitution. I know based on my quotient identities that tangent x squared is equivalent to sine squared over cos squared. And I'm going to sub in again. I'm going to sub sine squared divided by cos squared. I'm going to sub that in for tan squared. So now I have sine squared over cos squared times 1 over sine squared equals secant squared. I can algebraically cancel out the sine squared divided by sine squared to be 1. I'm going to move this problem up here. I now have 1 over cos squared x equals secant squared x. One last move here is that 1 over cos squared is equivalent to secant squared. I'm going to substitute that in. So I can replace 1 over cos with secant, and I will get secant squared x equals secant squared x. I'm going to finish with dot 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 QED dot dot dot, meaning therefore quod erat demonstratum, meaning I've proven what I was supposed to prove. This equation that I was given is indeed true, and I've shown that algebraically. The left and the right sides were indeed identical, even though they didn't look it initially. A challenge with a problem like this is there's not a single thought process. we need to manipulate to somehow reduce or somehow simplify one side, probably the more complex side, to be exactly identical to the more simplified side of the equation. So I'm going to give you two to work with today. The first one I'm going to leave you with is that the sine cubed of x plus the sine x times cos squared x equals the sine of x. The hint I'm going to leave you with for this one is factor a GCF. Think about which side is more complex, which side you can work down. The last question I'm going to leave you with today is that the cos x divided by 1 minus sine x minus the sine x over the cos x equals secant of x. The hint I'm going to leave you with on this one is to create an LCD, a least common denominator, on the left side. You cannot touch both sides. You can only manipulate one side. Good luck.